Hi, this lesson is on Geology Standard 3.5, the rock cycle and soil creation. In this lesson, we'll be discussing the three main rock types, igneous, sedimentary, and metamorphic rock, the rock cycle, and soil formation. Let's start by looking at the different rock types. There are three main rock types, igneous, sedimentary, and metamorphic. Igneous is rock formed from a volcano, so it's essentially hardened magma or lava. Sedimentary rock is formed from compressed sediments, so again, these are the little particles of rock that are squeezed together to form a whole new rock type called sedimentary rock. Now, what if we take an igneous rock or a sedimentary rock and expose it to even more pressure and temperature? Well, then it becomes a metamorphic rock. So again, a metamorphic rock is any rock that goes through more pressure and higher temperatures, and it's essentially changed into a whole new rock type. So let's look at each one of these now individually. The first one is igneous. And again, igneous is just rock formed from a volcano, so it's essentially hardened magma or lava. If you look in the picture below, do you see the white streaks? That shows the way that the lava was moving when it hardened. Okay, now we're on to sedimentary rock. Again, sedimentary rock is a rock formed from compressed sediments. There are three C's to sedimentary rock: compression, compaction, and cementation. Again, this just means that it's squeezed, compacted, and it essentially becomes hardened like cement. Okay, metamorphic. Again, this is just any rock type, can be igneous, can be sedimentary, that goes through even more pressure and hotter temperatures. This original rock then becomes a whole new rock type. So let's take a minute and do a quick rock type review. Do you remember the three types of rock? Can you define them? How are they different? Now we're moving on to the rock cycle. I realize that this can be really confusing, but if you take the time to look at the pictures, I think everything will start to make sense. First off, when we're talking about the rock cycle, it's important to realize that every rock and rock fragment on our Earth is a part of the rock cycle. This rock cycle is a beautiful example of how the Earth recycles everything. Our rocks are constantly changing, although sometimes these changes are so slow that we don't ever see it. So let's take a look at this picture of the rock cycle. Let's start in the lower left-hand corner where it says melting. As you know, subducted oceanic crust eventually melts under the hot temperatures. Well, this melted magma can come up and it can come out of a volcano where it forms igneous rock. Well, this igneous rock, now that it's on the surface of our Earth, is weathered by the rain and the wind, and eventually it's eroded away. Remember, erosion just means movement of those sediment particles. Well, look, it went down the river and now it's into the ocean where it's been deposited in the trench. Well, now it's being pressed down and it's being compacted to form that sedimentary rock. Well, remember, that oceanic crust is constantly subducting those, so now that sedimentary rock in our trench is going to be carried down and down where it's going to be exposed to more temperature and pressure and becomes metamorphic rock, and the whole cycle begins again. Here's another way of looking at it. This can be a bit more confusing, but I wanted to make sure you understood that it can go in multiple directions. Okay, so you can see in each corner you have a rock type: igneous, sedimentary, and metamorphic. Well, from each one you have a couple different options. For example, let's look at igneous. If igneous is eroded, it can become sedimentary rock. Or if igneous is exposed to heat and pressure, it can become a metamorphic rock. Alright, let's try this again. Let's start this time from metamorphic rock. If metamorphic rock melts, it can become igneous. Or if it erodes, it can become sedimentary. Do you see how every rock type has a choice or a say in what it becomes next? So, just for practice, pretend you're a certain rock type. Let's say igneous, for example. Where do you go from here? what does your future look like? Take a minute and plan out your life story as an igneous rock. Okay, now we're moving on to soil creation. What exactly is soil? Well, really, soil is just organic matter, sediment, air, and water. That's it. Some of those are pretty big words, so let's take a minute and break it down. What exactly is organic matter? Organic matter is just bacterial decay of plant and animal matter. Essentially, this is dead plants and animals. What about sediment? Well, again, we talked about sediment. This is just weathered down pieces of rock. So again, organic matter, sediment, air, and water all together makes our soil. Soil is also influenced by other factors, though, including climate, the parent rocks and minerals, and the organisms influencing. So if you take a look at the picture on the right, you see how all those soils look very different. Well, it could be because they're from different climate regions, or they could have different parent rocks and minerals, or they could have different organisms influencing them. So again, our rock types or soil types rather, are very different depending on where they're found. So if we look at this picture of global soil regions, you can see how very different the soils are depending on where they're found. I know some scientists can actually look at the composition of soil and pretty much pinpoint where it came from. Soil often is found in layers also. There are different soil types layered on top of each other. This can give us pretty much a history of that region, so it can show changes in the climate, the different rocks, or the organisms affecting them. So again, look at the picture on the right. Do you see how there are different layers? Each layer is its own story, and it's telling the story of whatever happened in that region at that time. Each layer may have a different texture, or even a different chemical composition, like it may be made out of something completely different altogether. Here's a beautiful example of a core sample. So a core sample is basically like taking a drill and being able to pull out just a small picture of the rock column. And you can see in this core sample there are very different rock types depending on the layer. It's pretty interesting, and it gives a beautiful history of that area. Well guys, that's actually it for this lesson. If you have any questions, please ask either me or Mrs. Ladner. I realize some of this can be pretty tricky, but if you take the time to follow through on those pictures or even the chart, I think you'll be able to make sense of it all. Again, I wish you luck, and don't feel ashamed to come ask us for help if needed. Alright, talk to you later.